Hello, everybody. I'm going to talk about ozone and some atmospheric processes that affect ozone levels in the United States. In the contents of this video, we will talk about what is ozone, the stratospheric ozone and the tropospheric ozone, where tropospheric ozone comes from and how it's formed, why is tropospheric ozone bad, how the El Nino Southern Oscillation and stratospheric intrusion affects U.S. surface ozone interannual variability. Just going to go over, what is ozone? So ozone is a special kind of oxygen molecule. Normal oxygen molecules, the kind we need to breathe, have 2 oxygen atoms. Ozone molecules have 3 oxygen atoms and are unstable and highly reactive. They're very prone to react chemically with other substances. Ozone is mainly found in 2 general locations in Earth's atmosphere. In the stratosphere, it's beneficial, and in the troposphere, it's a pollutant. Most ozone, about 90%, is stratospheric ozone, the good ozone, that resides in a layer of the atmosphere about 6 to 10 miles above the Earth's surface, extending to 30 miles. Stratospheric ozone is essential to life on Earth because it filters and absorbs most of the damaging ultraviolet sunlight, called UVB, allowing only a small amount to reach the Earth's surface. Before the ozone layer was formed, all life was in the ocean. It acts as a natural sunscreen. Stratospheric ozone, the good ozone, is produced naturally when high energetic solar radiation strikes molecules of molecular oxygen in the stratosphere and causes molecular oxygen to split apart in a process known as photolysis. When the freed oxygen atoms collide with another molecule of oxygen, it joins up, forming ozone. Ozone is also naturally broken down in the stratosphere by the same process. In an unpolluted atmosphere, there is a balance between the amount of ozone being produced and destroyed, so the total concentration remains relatively constant. Anthropogenic pollution has caused our stratospheric ozone layer to thin due to chemicals called chlorofluorocarbons, also known as CFCs, that react with the ozone layer. Chlorofluorocarbons are made of 1 fluorine atom, 1 carbon atom, and 3 chlorine atoms. A photochemical reaction with sunlight and the CFC molecule will break off a chlorine atom and bind to an ozone molecule, O3, and cause the ozone molecule to break into molecular oxygen and a free oxygen. That same chlorine atom acts like an enzyme and is not consumed in the reaction. 1 chlorine molecule can continue to break down over 100,000 additional ozone molecules. Tropospheric ozone, ground level ozone, the bad ozone, is found in the lowest level of the atmosphere where we breathe. It's a man-made pollutant. Tropospheric ozone develops in the atmosphere from anthropogenic pollutants, gases that come from incomplete combustion from automobile engines, industrial manufacturing, electric power generation, and other sources. These gases include nitrogen oxides, carbon monoxide, and volatile organic hydrocarbons. When these gases come in contact with sunlight and oxygen, they react to form ozone. Here is a simple diagram that shows how ground-level ozone is formed with sunlight and nitrogen oxides, volatile organic compounds equals ozone. Pollutants bake together in direct sunlight, forming ozone. Why is tropospheric ozone so bad? Why are we so concerned? Ozone affects human health, our environment, and the economy. In industrial and urbanized areas, the emissions of pollutants are more concentrated and cause problems. But atmospheric conditions such as surface air pressure, humidity, temperature, and wind speed also affect the dispersal of pollutants. Winds help distribute pollutants over a large area. Stable conditions, in particular the presence of an inversion, can greatly restrict vertical motions and concentrate pollutants near the ground. Effects of ozone on human health. Air quality directly affects our quality of life. Known human health effects of ozone pollution are respiratory problems that cause severe bronchial constriction, heart problems, reduced immunity to infections, and cancer. The most vulnerable are children and teens, the elderly, people of all ages who have lung diseases such as asthma and COPD, people with cardiovascular diseases, and people who work or exercise outdoors. Breathing ozone can trigger a variety of health problems, including chest pain, coughing, throat irritation, congestion, shortness of breath, and wheezing. Ozone has a bleach-like odor and can make your eyes burn too. During hot, sunny days, the concentration of ozone is higher, and at this time, the risk is greater. Effects of ozone on plants and crops. To the left shows a damaged leaf due to ozone. To the right shows a diagram of crop yields of certain plants that have decreased due to ozone concentrations. Because ozone formation requires sunlight, periods of high ozone concentration coincide with the growing season. Just as in damage to people, ozone damage to plants can cause without any visible signs. Many farmers are unaware that ozone is reducing their yields. Ozone enters the plant's leaves through its gas exchange pores, the stomata, affecting the plant by decreasing the number of flowers and fruits a plant will produce. They impair water use efficiency and other functions. Plants weakened by ozone may be more susceptible to pest, disease, and drought. Some crops are more susceptible to ozone than others. The Environmental Protection Agency has done a good job with supporting data regarding the concentrations of ozone. By going to www.airnow.gov, we can determine quality of air by state and/or zip code. Remember that the Air Quality Index is calculated each day for locations across the U.S. by applying a particular formula for ozone, particulates, carbon monoxide, sulfur dioxide, and nitrogen dioxide, and expressing each pollutant on a scale that ranges from 0 to 500. The official air quality index for any place at a particular time is the highest of the 5 individual pollutants values. The EPA has determined at an 8-hour mean of 70 parts per billion will be used as the standard. That being said, let's take a look at this map. This map of the United States shows the high-risk areas that exceed the EPA's 70 parts per billion standards. The greatest threat to health and agriculture from ozone in the U.S. is in the southwestern states. The areas marked red on the map regularly exceed an 8-hour mean of 70 parts per billion, but while central and northeastern states often hit levels of 70 to 80 parts per billion, parts of Southern California regularly exceed 107 parts per billion. Did you know that El Niño southern oscillation patterns affect tropospheric ozone levels? Typical El Niño winters reduces yearly ozone averages. Ozone levels in the southwest are highly dependent on climate, as well as levels of anthropogenic pollution. Days with little cloud cover and low humidity tend to have increased levels of ozone because more sunlight causes a greater rate of photochemical reaction, and ozone breaks down more quickly in humid air. The El Niño Southern Oscillation has an effect on ozone levels in the southwestern United States over interannual periods by affecting the weather. During El Niño periods, warm sea surface temperatures in the central Pacific causes wetter weather and more storms in the southwest, which generally reduces yearly mean ozone levels. During a winter La Nina cycle, we experience increases in yearly ozone averages. A La Nina event brings low sea surface temperatures in the central Pacific that causes a high pressure area in the North Pacific, pushing the polar jet stream further south. This action causes drier long-term averages over the Southwest, which increases yearly ozone needs. Areas around the polar jet stream also have a lower tropopause and ideal conditions, especially in the spring, for a process known as stratospheric inversion to take place. How stratospheric ozone intrusion affects U.S. surface ozone interannual variability. Let's take a look at this video. During events called stratospheric ozone intrusion, large fingers of ozone-rich air can fold into the troposphere from the stratosphere. In this model from NASA of an event in 2012, the blue swirling sheet above the map represents high levels of ozone in the stratosphere. The air is color-coded by altitude, with the deep reds reaching low into the troposphere from a low-pressure system moving in from the west brings high levels of stratospheric ozone to the ground. These events can increase ground-level ozone by 40 to 60 parts per billion in areas that already have the highest ozone pollution problems in the country. A better understanding of how interannual weather patterns affect ozone pollution will allow air quality planners to prepare, such as conducting daily forecasts for public health alerts and deploying targeted measurements aimed at identifying exceptional events. In conclusion, we have learned stratospheric ozone and tropospheric ozone are the same molecules but are made by entirely different processes. High levels of tropospheric ozone are unhealthy to people, the ecosystem, and our economy. El Niño events typically reduce ozone concentrations. La Niña events typically increase ozone concentrations. Stratospheric intrusions occur most often in spring and early summer and also increase daily ozone concentrations. So how ozone is formed is with sunlight plus nitrogen oxides, volatile organic compounds, and oxygen, it forms ozone.